Shield AI confirms VBAT deployment in Ukraine. On January 13, 2025, Shield AI, a defense technology firm based in the United States, officially confirmed the deployment of its VBAT drones in Ukraine. This announcement not only underscores the technological advancements in military applications but also highlights the strategic significance of unmanned aerial vehicles (UAVs) in contemporary warfare. Overview of VBAT capabilities. The VBAT drone features a vertical takeoff and landing VTOL design, making it uniquely suited for operations in varied and challenging environments. With a length of 9 feet and a wingspan of 9.7 feet, the VBAT can carry a payload of up to 25 pounds. It boasts an impressive service ceiling of 20,000 feet and an endurance of over 10 hours depending on payload and mission configurations. The drone is designed to perform intelligence surveillance and reconnaissance ISR missions, making it an invaluable asset in modern military operations. Timeline of events. June 2024, Shield AI first confirmed the initial deployment of VBAT drones in Ukraine. Following this, the drones were involved in numerous missions, reportedly completing 23 deployments, showcasing their resilience and effectiveness in electronic warfare scenarios. September 2024, Shield AI demonstrated the autonomous collaboration of 3 VBAT drones using Hivemind AI software. This technology allowed the drones to execute complex tasks without reliance on GPS or communications, thereby simulating real-world operational conditions. December 31, 2024, in its year-end newsletter, Shield AI highlighted the VBAT's successful completion of a long-endurance reconnaissance mission in Ukraine, emphasizing the drone's ability to operate effectively even under electronic warfare conditions where GPS and communications were jammed. January 2025, reports surfaced emphasizing the strategic importance of VBAT drones in dynamic combat scenarios, with a focus on their enhanced capabilities in ISR tasks. Key technical features. 1. Autonomy and coordination. The VBAT's advanced autonomy allows it to manage its tasks independently, significantly reducing the workload for operators. The goal is for a single operator to control up to 10 drones simultaneously, enhancing operational efficiency. 2. Electronic warfare resilience. The deployment of VBAT drones in Ukraine has demonstrated their capabilities against electronic warfare tactics, allowing them to maintain operational effectiveness under conditions typically designed to disrupt UAV operations. 3. Versatility. Beyond military applications in Ukraine, VBAT drones are also being utilized in various global operations, including anti-drug trafficking missions in the Caribbean, showcasing their adaptability to different operational contexts. Strategic implications. The deployment of VBAT drones in Ukraine is a clear indication of the increasing reliance on autonomous systems in modern military strategies. As warfare continues to evolve, the ability to conduct ISR operations with minimal human intervention is becoming crucial. The resilience of VBAT against electronic warfare not only enhances battlefield intelligence but also provides a strategic advantage in countering adversarial tactics. Moreover, the successful operationalization of VBAT drones could influence future military procurement strategies as nations seek to integrate more advanced autonomous systems into their defense frameworks. The emphasis on reducing operator workload through enhanced autonomy also points towards a broader trend in military technology where efficiency and effectiveness in operational planning are paramount. Conclusion. Shield AI's confirmation of VBAT deployment in Ukraine marks a significant milestone in the integration of advanced drone technology into military operations. The capabilities demonstrated by VBAT drones highlight the importance of autonomous systems in addressing contemporary warfare challenges. As military conflicts evolve, the role of such technologies will likely expand, influencing future strategies not only in Ukraine but globally. The ongoing success of the VBAT could set a precedent for the adoption of similar technologies across various military applications, reinforcing Shield AI's position as a leader in the field of autonomous defense systems. Counterintuitive information in the deployment of VBAT drones in Ukraine. 1. Autonomy versus control. While one might assume that the presence of advanced drones like the VBAT would imply a higher degree of human control in military operations, the opposite is true. Shield AI's VBAT drones are designed to operate with a significant level of autonomy, enabling a single operator to manage multiple drones simultaneously. This reduces the cognitive load on operators who can focus on strategic decisions rather than routine controls. This shift toward autonomy highlights a counterintuitive trend where machines take on more decision-making roles in combat scenarios, potentially challenging traditional military hierarchies and operational methods. 2. Electronic warfare resilience. It is common to think that advanced technology like drones would be vulnerable in high-intensity conflict environments, especially against electronic warfare tactics designed to jam communications and control signals. However, the VBAT drones have demonstrated resilience against such tactics, successfully completing missions even when GPS and communication systems were compromised. This resilience suggests that the integration of AI and autonomous capabilities can enhance the survivability and effectiveness of unmanned systems in contested environments, contrary to the expectation that they would be easily disrupted. 3. Operational costs versus capabilities. Typically, one might assume that advanced military drones would come with prohibitive costs and limited deployment. However, Shield AI claims that the VBAT provides Group 5 capability at Group 3 costs, meaning that it delivers high-end functionalities typically associated with more expensive systems at a lower price point. This challenges the conventional wisdom that advanced military technology must also be the most costly, potentially democratizing access to sophisticated defense solutions for various military forces. For civilian dual-use applications, the deployment of military drones often raises concerns about their potential for misuse or collateral damage in civilian contexts. However, the VBAT's capabilities have been demonstrated in non-military scenarios such as detecting wildfires, showcasing their versatility and hinting at a broader application of military technologies in civilian domains. This dual-use capability contradicts the perception that military technologies are solely designed for conflict, emphasizing their potential for contributing positively to civilian safety and efficiency. 5. Resistance to jamming. The assumption that all drones are susceptible to jamming and other electronic warfare tactics is proven incorrect by the VBAT's operational history in Ukraine. The successful execution of missions despite jamming scenarios indicates that not all unmanned systems are equally vulnerable to these tactics. Such resilience could lead to a re-evaluation of how military planners approach electronic warfare, potentially leading to a shift in strategies that account for the evolving capabilities of modern UAVs. 6. Complex task coordination. It may be expected that coordinating multiple drones for complex missions would require extensive human oversight and communication. However, the VBAT drones demonstrated their ability to work collaboratively in a coordinated manner using AI, completing tasks without reliance on GPS or real-time communication. This challenges traditional views on the necessity of constant human oversight in UAV operations, indicating that advanced AI can manage intricate tasks independently. 7. Broader strategic implications. The successful deployment of VBAT drones in Ukraine may lead to a rethinking of military strategies globally. As other nations observe the effectiveness of autonomous systems in combat, there could be a pivot towards integrating similar technologies. This could alter the balance of power in military capabilities, suggesting that nations with access to such technology may gain tactical advantages, contrary to the expectation that traditional military strength alone dictates outcomes in warfare. The deployment of VBAT drones in Ukraine illustrates a range of counterintuitive insights that challenge established perceptions about military technology operational control and the role of autonomy in modern warfare. These developments not only highlight the capabilities of advanced drone technology but also suggest significant shifts in the future conduct of military operations globally. The recent confirmation by Shield AI regarding the deployment of its VBAT drones in Ukraine is a pivotal development in the context of modern warfare and defense technology. While many aspects of this report have been discussed, several critical elements may be overlooked by the general audience, yet they carry significant implications for military strategy, technology adoption, and future conflicts. 1. Autonomy in combat operations. One of the most important aspects of the VBAT deployment is its advanced autonomy. The VBAT can operate independently in challenging environments, particularly under conditions where GPS and communication systems are compromised. This capability is not just a technical achievement, it represents a paradigm shift in how military operations can be conducted. Significance: the ability of the VBAT to perform complex tasks without real-time human intervention reduces the risks associated with human operators on the battlefield. It allows the military to conduct operations in hostile environments where traditional command and control may be hindered. This autonomy can lead to faster decision-making and the ability to adapt to rapidly changing situations, which is crucial in modern warfare. 2. Resilience against electronic warfare. The report indicates that the VBAT has demonstrated resilience against electronic warfare tactics employed by adversaries. This is particularly relevant in the ongoing conflict in Ukraine, where both sides have increasingly relied on electronic warfare to disrupt operations. Significance: the ability of the VBAT to withstand electronic jamming and continue its missions underscores its value in contemporary conflicts where electronic warfare is a common strategy. This resilience can provide a tactical advantage and ensure that critical ISR intelligence, surveillance, and reconnaissance missions can be completed even in the face of sophisticated countermeasures. 3. Multi-domain applications. While the VBAT's deployment in Ukraine focuses on military applications, the report also highlights its use in civilian scenarios, such as anti-drug trafficking operations in the Caribbean. This dual-use capability showcases the versatility of the drone and its potential applications beyond traditional combat roles. Significance: the ability to adapt military technology for civilian purposes can lead to broader acceptance and integration of such technologies into various sectors. It also opens up avenues for collaboration between defense and civilian agencies, potentially enhancing domestic security and law enforcement efforts. 4. Scalability of operations. The mention of the VBAT's potential for a single operator to manage multiple drones simultaneously is a crucial detail that is often overlooked. This scalability is a significant advancement in drone technology, indicating a shift towards swarm tactics where multiple UAVs can operate in concert. Significance: this capability can dramatically increase operational efficiency and effectiveness in scenarios where situational awareness is critical. Being able to deploy multiple drones for reconnaissance or attack can overwhelm an adversary and provide a comprehensive view of the battlefield. It also reduces manpower requirements, allowing military forces to allocate human resources more effectively. 5. Technological leadership and strategic implications. Shield AI's advancements in drone technology position it as a leader in the defense sector, particularly in the realm of autonomous systems. The company's commitment to enhancing the autonomy of its drones reflects a broader trend within the defense industry towards AI and machine learning. Significance: as military organizations around the world increasingly adopt autonomous systems, the strategic landscape of warfare will likely evolve. Nations that lead in these technologies may gain significant advantages, influencing global military dynamics and shaping future conflicts. 6. Potential for global military sales. The success of the VBAT in Ukraine could have implications for Shield AI's market position and the global defense industry. Other nations observing these capabilities may seek to procure similar technologies for their military operations. Significance: if the VBAT proves to be a game-changing asset in Ukraine, it could lead to increased demand for the drone from other countries facing similar security challenges. This could not only boost Shield AI's revenues but also accelerate the proliferation of advanced drone technologies worldwide, influencing how conflicts are fought in the future. 7. Ethical considerations and operational risks. While the advancements in drone technology offer numerous benefits, they also raise ethical questions regarding the use of autonomous systems in warfare. The potential for drones to make life and death decisions without human oversight is a contentious issue that warrants careful consideration. Significance: as militaries adopt more autonomous systems, the risk of unintended consequences increases. There is a growing need for robust ethical frameworks and regulations governing the use of such technologies to prevent misuse and ensure accountability in military operations. Conclusion: Shield AI's confirmation of VBAT deployment in Ukraine is more than just a technical achievement, it is a reflection of the future of warfare. The overlooked aspects of autonomy, resilience against electronic warfare, scalability, and ethical considerations are all critical to understanding the broader implications of this technology. As nations continue to invest in and deploy autonomous systems, the landscape of military operations will undoubtedly change, presenting both opportunities and challenges that will shape global security dynamics for years to come. 1. Operational effectiveness in high-intensity conflicts. The deployment of Shield AI's VBAT drones in Ukraine underscores their operational effectiveness in high-intensity conflict zones, particularly in countering electronic warfare. The drones have shown resilience against jamming and other electronic interference, which is increasingly prevalent in modern warfare. This capability enables them to maintain operational integrity and complete missions even in challenging environments where traditional systems might fail. The successful execution of long-endurance reconnaissance missions under these conditions highlights the VBAT's role in enhancing situational awareness and intelligence gathering, which are critical for military strategy. 2. Autonomy and AI integration. The integration of advanced artificial intelligence through the Hivemind AI software represents a significant advancement in drone technology. The ability for multiple VBAT units to autonomously coordinate and execute complex tasks without reliance on GPS or communication systems demonstrates the potential for increased operational efficiency. This autonomy allows a single operator to manage multiple drones, reducing workload and enabling rapid adjustments to mission parameters. As military operations continue to evolve, the shift towards autonomous systems like the VBAT could redefine operational paradigms and improve response times in dynamic combat scenarios. 3. Versatility across applications. While the VBAT drones have shown notable success in military applications, their design and functionality also suggest versatility for civilian applications, such as environmental monitoring and disaster response. The successful simulation of wildfire detection tasks indicates that the technology could extend beyond military use into broader applications, thereby enhancing the strategic value of the drones. This dual-use capability could attract interest from various sectors, facilitating further investment and development in drone technologies. 4. Strategic implications for future warfare. The deployment of VBAT drones in Ukraine signals a shifting landscape in military strategy where autonomous systems play an increasingly pivotal role. The success of these drones may influence future military procurement and operational strategies, emphasizing the need for nations to invest in similar technologies. As the demand for autonomous and intelligence systems grows, the advancements demonstrated by the VBAT could set new standards for military capabilities and operational planning, potentially reshaping how conflicts are approached and managed in the future. 1. The use of drones in the war in Iraq 2003 to 2011. During the Iraq War, the United States extensively utilized unmanned aerial vehicles (UAVs) for intelligence, surveillance, and reconnaissance (ISR) missions. One of the most notable UAVs was the MQ-1 Predator, which played a crucial role in targeting insurgents and gathering real-time intelligence. The deployment of drones marked a significant shift in military operations, allowing for remote engagement in combat zones while minimizing risks to human pilots. The adoption of drones in Iraq highlighted their effectiveness in dynamic combat scenarios similar to the recent deployment of the VBAT in Ukraine. 2. The Battle of Stalingrad 1942–1943. The Battle of Stalingrad is one of the most significant battles of World War II, where the Soviet Union successfully defended the city against the German army. This battle showcased the importance of strategic intelligence and the use of technology in warfare. The Soviets employed various tactics, including the use of snipers and superior artillery, to counter the German forces. The technological advancements during this period, such as improved communication methods and the use of reconnaissance, can be compared to the current deployment of advanced drones like VBAT, which utilize AI and autonomous capabilities to enhance military operations. 3. The Vietnam War and the development of UAVs 1960s to 1970s. The Vietnam War saw the initial development and deployment of UAVs for reconnaissance purposes. The Ryan Firebee drones were used to gather intelligence over enemy territory, marking a significant advancement in military technology. These early drones faced challenges similar to those faced by modern UAVs, including electronic warfare and the need for effective communication systems. The evolution of UAV technology from the Vietnam War to the present day, including the deployment of the VBAT in Ukraine, illustrates the ongoing trend of integrating unmanned systems to enhance military capabilities and operational effectiveness. Future outlook: predictions for autonomous military systems and the VBAT drone. As the deployment of Shield AI's VBAT drone in Ukraine highlights the evolving landscape of modern warfare, several key predictions can be made regarding the future of autonomous military systems and the broader implications of this technology. 1. Increased adoption of autonomous systems. The success of VBAT drones in challenging environments such as Ukraine is likely to accelerate the adoption of autonomous systems across global military forces, as nations seek to enhance their operational capabilities while minimizing risks to personnel. The demand for drones that can perform complex tasks autonomously will rise. This trend will lead to faster development cycles and increased funding for research and development in autonomous UAV technologies. 2. Enhanced autonomy and collaboration. Future iterations of the VBAT and similar drones will likely see significant advancements in autonomy. Shield AI's goal to allow a single operator to manage multiple drones simultaneously is a precursor to a more interconnected and collaborative approach to drone operations. We can expect to see further advancements in AI algorithms that enable real-time decision-making, allowing drones to adapt to dynamic combat situations without human intervention. 3. Integration with other military technologies. The VBAT's capabilities in ISR intelligence, surveillance and reconnaissance, and its resilience against electronic warfare will likely lead to its integration with other military technologies such as ground robots, manned aircraft, and naval vessels. This integration can create a comprehensive battlefield network that enhances situational awareness and operational efficiency. 4. Countermeasures and electronic warfare. As the use of drones becomes more prevalent, adversaries will develop countermeasures to neutralize these threats. Future autonomous systems will need to include advanced electronic warfare capabilities to ensure their survival in hostile environments. This scenario will drive innovation in countermeasure technologies, resulting in a continuous arms race between drone capabilities and electronic warfare strategies. 5. Civilian applications and dual-use technologies. The advancements in VBAT technology will not only benefit military operations but also civilian applications. The capabilities demonstrated in Ukraine, such as autonomous reconnaissance and disaster response, can be adapted for use in search and rescue missions, environmental monitoring, and law enforcement. This dual-use potential will spur interest from various sectors, leading to collaborations between defense contractors and civilian technology firms. 6. Regulatory and ethical considerations. As autonomous drones become more common on the battlefield, ethical and regulatory challenges will emerge. Nations will need to establish guidelines governing the use of autonomous systems in combat, including accountability for actions taken by drones and the implications of AI-driven decision-making in warfare. This will likely result in international discussions and agreements focused on the responsible use of military technology. 7. Global military dynamics. The deployment and success of autonomous systems like the VBAT in conflict zones will have a profound impact on global military dynamics. Countries that invest heavily in drone technology may gain strategic advantages over those that do not, leading to shifts in power balances. Additionally, as more nations acquire similar technologies, regional arms races may emerge, prompting increased military spending and adjustments to defense strategies. 8. Public perception and acceptance. The effectiveness of drones in military operations may influence public perception of autonomous warfare. As citizens observe the successful deployment of drones in critical missions, there could be growing acceptance of their use. However, concerns around privacy, safety, and the potential for unintended consequences will continue to challenge this acceptance, necessitating transparent communication from military leaders and defense companies. In conclusion, the future of autonomous military systems, exemplified by Shield AI's VBAT drone in Ukraine, is poised for rapid evolution. As technological capabilities advance, military strategies will adapt, leading to new operational paradigms that prioritize efficiency, safety, and effectiveness in warfare. The intersection of military and civilian applications will further enrich the landscape, making it a critical area for ongoing observation and analysis.